of seconds, we will be live in Facebook. I will also record this for our reference later. Actually, no need na kasi nandun naman siya sa Facebook. Facebook, sa YouTube, we can always review. Okay, so let's start. So good morning, good afternoon again, everyone. I welcome everyone no sa ating viewers sa ating Facebook, sa ating YouTube. Don't forget to click subscribe for more um, videos about the data science degree program. So today we're going to listen or watch the presentation of the first cohort of data science students in UP Mindanao. So this forms the final project requirement for the course DS19, which is the Introduction to Data Science. So there will be no question and answer. So this is purely a presentation, and each group is allotted 10 minutes. So I might give you some extension up to 30 minutes to wrap up your presentation. And the order of our presentation would be: first group will present fake news identification using machine learning algorithms, followed by detection and classification of rice leaf diseases using convolutional neural network, sentiment analysis for restaurant reviews, predicting consumer shopping cart abandonment in e-commerce stores, machine learning application and traffic forecasting, enhancing student experience through AI, predicting fish abundance times using chlorophyll A, balancing priorities, analyzing the impact of health expenditure on the gross enrollment ratio of leading countries in education, empowering road society, a Python-powered driver dosage detection system, and the last project is enhancing UP jeepney route optimization through a heuristic-driven algorithmic approach. So let's start with the first team, with the first presentation, which is the fake news identification using machine learning algorithms. This project is uh, completed by Ellen Faith Lamson, Amando Vicente Mendoza, and Wenden Shane Balboa. So you may start now.
Okay, so good afternoon, everyone. Today we will present our project titled Fake News Identification Using Machine Learning Algorithms, or MLA. So here is the agenda for today, and we will discuss the background of the problem, objectives, methods, result and discussion, conclusion, and finally, recommendation. So to start, fake news is a problem as it can affect our perception about a certain event, topic, or belief. Now, due to the rapid growth of technology, it is much easier to spread fake news nowadays, and this poses a problem. Conflicts may arise due to misinformed citizens, and this will affect society as we know it. That is why this paper aims to identify fake news to avoid the spread of misinformation. Other papers in the past have also used machine learning algorithms to identify fake news. One such study is by Akhar et al. In 2023, in which they used artificial intelligence and machine learning algorithms to identify fake news that may disrupt supply chains. Other relevant studies have used different machine learning algorithms as well, such as neural networks, natural language processing, and many others. So the objectives of this paper are the following. First is to find the best algorithm with the highest accuracy, and second is to create a model that can accurately identify fake news. So I'll give the floor to Wendy, who will present the data.
Now, for the primary data source of our study, it is the well-fake dataset as compiled by Verma et al. In 2021 that is available on Kaggle. This dataset consists of 72,130 news articles and 28 marked as real and 37,000. The dataset is organized into 4 columns: serial number, title, text, and label, where 0 signifies real and 1 indicates fake. The entire dataset has a set of approximately 245,000.9 megabytes. Now, let's proceed to the next slide.
Good day, everyone. I will be presenting the data science techniques of this project. So during the data pre-processing phase, first we clean the data set by removing the noise such as dots, commas, and quotations, and tokenize each words and remove the stop words. During the EDA phase, we discovered a mislabeled data from Kaggle that switched the labels of real and fake news. We validated these findings using the paper of Verma et al. That used this dataset, and indeed it is switched. That is why it is important to conduct an EDA on the dataset first. So moving on, we adopted 4 features from Manzor et al., such as the word count of the news, the average word length of the article, and number count. So for this project, we adopted the method of Verma et al. That use word embedding techniques over 4 features. Next slide, please. On the model building phase, we experimented with 3 models: the random forest, naive Bayes, and logistic regression, to test the performance of each model. For this, we can see that the random forest with count vectorizer as word embedding achieved a 94.3% accuracy, 94% precision, recall, and F1 score. So for the precision, you can think of it as of all the things that the model said were true, how many were actually true. And for the recall, you can think of it as of all the things that were actually true, how many did the model correctly identify. So the effort score is the balance between the precision and the recall. So we can also see that the naive Bayes with the TF-IDF vectorizer as a word embedding technique achieved an accuracy of 87%, along with the precision, recall, and F1 score. And the logistic regression with with a 4 lexical features over the word embedding techniques, the TF-IDF vectorizer achieved a 95% accuracy with stop words and 94.5% accuracy without removing the stop words. And then the count vectorizer achieved a 95% accuracy with the stop words removed. So we can see that the best performing model of this project is the logistic regression that achieved a 96.4% accuracy, precision, recall, and F1 score. Next slide, please. Hence, this project primarily focused on politics, and the models we used are the random forest, the naive Bayes, and the logistic regression. So for the performance metrics of the naive Bayes and random forest models with 1 feature over the 2 WE techniques, the naive Bayes with TF-IDF vectorizer achieved a 97% accuracy, and the random forest with the same technique achieved a 91% accuracy. And our model, the logistic regression, which is our best performing model, with 4 lexical features experimenting over the WE techniques. Next slide, please. This is our confusion matrix. So for this, we use the logistic regression over the TF-IDF word embedding techniques, and it achieved an accuracy score of 94%. And the logistic regression with the count vectorizer word embedding technique achieved a 96.4% accuracy. So that is all for the results and discussion. Thank you.
Now, for our conclusion. In our pursuit of effective fake news identification, we explored 3 machine learning models: random forest, naive Bayes, and logistic regression. The logistic regression consistently outperformed, displaying strong capabilities in identifying real from fake news, The logistic vectorizer word embedding achieved a 96.4% accuracy. This outstanding precision highlights its effectiveness in binary classification, effectively distinguishing between real and fake news articles. It proves to be a powerful tool in the ongoing fight against misinformation, especially in our country. In conclusion, our project really shows the effectiveness of machine learning, particularly logistic regression, in identifying real from fake news. And that is all for the conclusion part. Let's proceed in the recommendations. Now for the recommendations, we have fast-checking collaboration, the need to integrate the model with fact-checking website for cross-verification, ensuring accuracy and reliability, and model feature exploration, experiment with other features that can address emerging patterns of misinformation and improve accuracy over time, deploy the model, and localize the news in the Philippines. That is all for our presentation. Thank you.
Congratulations, fake news team. It's a very good work on this fake news detection, and it is very relevant, nowadays, especially that fake news is proliferating, in the online space. So maybe you can extend this study, no, to make it a full-blown study, and maybe in the future we can use your models in detecting and also fighting the proliferation of fake news. So thank you and congratulations, fake news team. So let's proceed to the next presentation, which is on the detection and classification of rice leaf diseases using convolutional neural network, completed by Kisha Rivero, Carl Michael Pacot, and Ivy Rinconada. Take it away.
A pleasant day, our distinguished viewers and guests. I am Ivy Rinconada together with Ms. Kesha Guevara and Mr. Carl Michael Pacas. We are thrilled to present our final project entitled Detection and Classification of Rice Leaf Diseases using Convolutional Neural Networks. Without further delay, let us delve into the problem our group wanted to address. Rice is one of the most nutritious crops all over the world, whose cultivation and level of production have a crucial impact on the development of the agricultural economy. Unfortunately, the Philippines, despite being an agricultural country, faces a challenge in rice production, leading to a reliance on imports. This issue stems from various factors. This includes the lack of continuous monitoring. As highlighted in Prajapati 2017, some farmers are unaware of the occurrence period of specific rice diseases. This lack of knowledge leads to the delay in detecting and treating these diseases, resulting in reduced crop yield. Another factor is the lack of familiarity in rice disease characteristics. Diseases may exhibit similar colors but vary in shapes, or have different colors with identical shapes. This can be a confusing factor for farmers, potentially leading to incorrect treatments and ineffective outcomes. Next is inefficient disease detection methods. As stated in the study of Deng et al. 2021, most farmers in the Philippines rely on manual inspection in identifying and classifying rice diseases. While this method may be practical and cost effective, it is also time consuming and can be inaccurate. Therefore, to overcome all these problems, our project leverages technological advancement to enhance disease management, maximize yield, and reduce crop monitoring costs for farmers. With the implementation of this rice disease detector, farmers can take timely actions to prevent yield loss and ensure a healthy crop. This in turn can increase their profits and contribute to the overall growth of the agricultural sector, which also aligns with the growing global demand for the rice production.
Good day, everyone. Today, I'll guide you through the methodology employed in our project. So we began by gathering our dataset from Kaggle, consisting of 7,123 RGB images spanning 5 classes: bacterial leaf blight, rice blast, brown spot, virus, and healthy rice plants. These images depict diverse backgrounds and resolutions, which will enhance the robustness later in our model training. So what do I mean by that? So to a computer, images are just numbers. And since we collected RGB images, each of the panel or pixels consists of 3 images stacked together in a 3 two-dimensional matrix. So the challenge we are trying to address here is how images exhibit various 3-dimensional variations. So we hope to utilize a robust computer vision algorithm employing neural network to not just recognize semantic elements, but also to extract features from pixel level patterns in a hierarchical manner. So next slide, please. So to prepare our data for model training, we undertook several essential steps. The first one is the train validation test split, in which we split the dataset into 80% training, 10% validation, and 10% for testing. Previous slide, please. So essentially, the validation will be used during the training process when we run each epoch. So once we are done through 15 epochs, which are just 15 iterations, we will use the 10% test data. So that will test the performance of our model. So next is the caching and prefetching. So to expedite the training process, we implemented caching to store images in memory and prefetching to anticipate subsequent batches, especially if the GPU is busy training. So this will optimize our data loading efficiency. So next is the pre-processing steps. So the first thing we did was scale using the TensorFlow Keras sequential class, which is essentially just a class from the library that we used in building our model. So we normalized pixel values through rescaling and standardized input dimensions to 300 by 300 pixels. This fosters the training stability of our model. Next is the data augmentation. So we enrich the training data set by applying transformations such as random flips and rotations, which will essentially enhance the model's resilience to diverse conditions and improve its generalization capability. So for example, if farmers were to input new images that our model doesn't recognize, then it will be able to predict the classes of the diseases still. So next slide, please. Next is our model building. So we constructed a convolutional neural network, or CNN, specifically designed for image recognition tasks, and trained that network on our trained dataset and measured accuracy using the same test dataset. So the architecture comprises of 12 layers, which include the two-dimensional convolutional layer, max pooling layers, the two dense layers, and an output layer utilizing the softmax function. So filters and activation function, here we employed 16, 32, 64, 128, and 256 filters within the convolutional layers and applied the ReLU activation after every convolutional operation. So this basically replaces all negative values by 0, which is important because it allows us to deal more effectively with images which are extremely non-linear. So that's what the ReLU activation do. So at this point, our model architecture is ready. However, we are not done training yet. So the convolutional and pooling outputs the high-level features that are extracted from our input. So the next step is to use the features and detect their presence in order to classify the image. So to do this, we use the softmax function to feed these outputted features into the fully connected layers to detect what class we are in. Next would be the model training. So after defining the neural network architecture, we compile using optimizers. So we use the Adam optimizer, and we then monitored the training progress through parameters such as loss, accuracy, validation accuracy, and validation loss. Then the model was trained over multiple iterations, or in this case, our epochs. And to refine its ability to accurately classify the rice leaf diseases. Next is plotting our training history. So we plot the training versus validation accuracy in a nice matplotlib chart. So for each parameter of loss and accuracy, since we have 15 epochs, we also have 15 values. So later on, during the results and discussion, you'll see the chart and how it started with just 50% accuracy to a very high one. So next is the inference and prediction. So following training, the model demonstrated its capability to classify unseen images with accuracy. So it generated predictions accompanied by confidence scores, showcasing its potential for real-world applications in rice cultivation. So the final step in model building would be saving our model. So to facilitate future use and advancements, we preserve the training model to disk using TensorFlow's Keras API. So this enables the deployment in practical scenarios. Now let's dive into the key findings of our project. Next slide, please. So this is the performance analysis of our project. So while training, our model completes 15 epochs with an average time of 35 seconds per epoch. So thanks to our GPU's acceleration. So as we can see with the graph, the final results are impressive with a model accuracy of 96.33% and a remarkably low loss of 0.086 per. So this indicates that our model's successful learning and generalization from training data was a success. So next slide, please. So figure 2 displays the accuracy and loss metrics over the 15 epochs. So, go back to the previous slide. So here, the orange line represents the validation accuracy consistently rising slightly higher than the training accuracy. In here, we actually so the overall downward trend in loss and upward trend in accuracy, it demonstrates the model's effective learning and dynamics. So it's evident that the model generalizes well to unseen data, which are supported by the lower validation loss. So next slide, please. Here is our confusion matrix. So the confusion matrix shows that our CNN model excels in classifying rice leaf diseases. In here, we can see that true positives and true negatives dominate the diagonal values, which showcase the model's high accuracy. So although 27 misclassifications occurred, the precision values, recall, and F1 scores ranging from 94% to 100% validate the model's effectiveness. So overall, the model achieves a commendable accuracy of 96%, accurately classifying plant conditions in a majority of 736 instances. So now let's compare our model to previous studies. A study done by Liang and several others in 2019 achieved 95.82% accuracy with a combined CNN plus SVM approach. So another study by Liu in 2017 achieved 91.90% accuracy. So in contrast, our model outperforms both, achieving 96.33% accuracy. So I will give the floor to my other member.
So for our conclusion, in the ever-evolving landscape of agriculture, the integration of our cutting-edge rice leaf disease detection system empowered by convolutional neural network or CNN not only empowers farmers with timely interventions for preventing yield loss but also fosters a robust foundation for thriving national rice industry by bolstering the accuracy of disease identification optimizing resource allocation, and addressing climate-induced challenges, this innovative technology emerges as a cornerstone not just in securing individual farmers' financial viability, but also in propelling the broader objectives of food security, economic prosperity, and environmental sustainability, both within Philippines and on a global scale. So we have two for our recommendations. So for our recommendations, we have two recommendations. First is to enhance the model, improve the reliability and robustness of our model on different data sets, preferably from other regions. In order to elevate the effectiveness of our model, it is imperative to focus on enhancing its reliability and robustness across diverse data sets. Preferably sourced from various regions, this strategic approach ensures the adaptability and resilience of the model, contributing to its broader applicability and success in real-world scenarios. For our second recommendation is to collaborate for real-world deployment, deploy the model in real-world scenarios, prepare an app or a website that a user can interact with. So to translate our advancements into practical impact, the next crucial step is to collaborate for real-world deployment. This involves deploying the model in authentic scenarios, culminating in the development of a user-friendly app or website. This user interface will seamlessly connect users with the model, fostering meaningful interactions and facilitating the practical application of our technology in diverse settings. So that's all for our presentation, sir.
Thank you so much, Rice. This is Tim, and congratulations to your very informative presentation. And in fact, there are so many potential application of data science in the field of agriculture. And this one just shows us one of those applications. And this problem is really very relevant in our situation because currently we are experiencing one of the largest importers of rice. So before, we are like the top rice producer, and we are able to train different experts, regarding rice cultivation. But now what happens is that the local supply is cannot meet the demand for rice. And partly because of the impact of several calamities. You have typhoon and also by the effect of disease. So maybe this model, we can use this, we can deploy this so that it can also help farmers detect and maybe mitigate the effects of rice disease on the rice yield. So thank you so much, Rice. This is Tim. Let's proceed to our next presentation, which is on the sentiment analysis for restaurant reviews, completed by Rowan Strichel Canyon, Kate M. Caro, and Hanuvi Dopio. Take it away, sentiment analysis team.
Good afternoon, everyone, and we are the Group 3, and we're going to present our project entitled Sentiment Analysis on Restaurant Reviews. For the background of our problem, did you know that restaurants contribute 4% gross domestic product to the economy around the world? Over 10% of the America's economy is from business restaurants alone. Restaurants play a crucial role in us customers since they are important meeting places for communities where people develop bonds and create memories. However, during the COVID-19 pandemic, most dining establishments witnessed a drastic drop in revenue, compelling them to reduce their workforce around the globe. There are many studies around the world about how the human person affects their emotion and reaction towards any restaurants during the COVID-19 pandemic, such as the study of Gursoy and Chico 2020, in which they stated that the pandemic induced measures such as travel restrictions, social distancing, and regulations limiting restaurants' takeout orders, which led to diverse lived experiences and reactions of the people. Reviews are essential to business holders as they can make informed decisions by analyzing opinions about their businesses. On the other hand, it also plays a pivotal role for customers, allowing them to assess the quality of specific business or product. It was corroborated by Medhad et al. 2023 that sentiment analysis methods are frequently used in restaurant industry to analyze reviews posted to online platforms. This approach enables the automated extractions and purposing of textual information to discern sentiments conveyed with opinions. Therefore, the proponents decided to conduct a project which highlights the sentiments of the customer reviews of the restaurants around the world with the help of sentiment analysis and other approaches to easily accurately identify sentiments expressed in text for efficient analysis. Next slide, please, for the objective. The sole purpose of the study is to analyze and interpret the customer's reviews of a restaurant by utilizing sentiment analysis to gain meaningful and substantial interpretation that can benefit the business restaurants industry as well as the customer's preference.
Thank you, Rowan, for that very comprehensive background. And now I will discuss the methodology of our project. First, we started with data gathering, in which we initially planned to get our data within UP premises. However, due to lack of respondents and time constraints, we opted to use a dataset from Kaggle. Next, we have text preprocessing. This is a very tedious process, so I'll only mention the text preprocessing that we conducted to our data. We have building a corpus for reading across various formats, removing noise, which includes punctuations, white space, and numbers. Next, we change the data into lowercase. And lastly, we eliminate the stop words, which involves common words such as prepositions and conjunctions. The next process is building document term matrix. The pre-processed text data was converted into a term document matrix, in which this represents the frequency of terms in the corpus, providing a structured format for subsequent analysis. For data classification, we utilize the NRC Emotion Lexicon, which comprises of 5,636 English words, and each is linked to 8 basic emotions as well as 2 sentiments, which is negative and positive. But in this study, we only use the 2 sentiments because those 8 sentiments weren't part of this study. The NRC lexicon is employed for data classification, specifically in determining whether the tested data falls into positive or negative sentiment category. This involves initial labeling, which using the naive Bayes classifier method, which includes 2 key processes, training and testing. Next, we visualize our data, such as in forms of bar charts and word cloud were created, in which these bar charts and word cloud were created to visualize and represent the overall frequency of words, overall frequency of positive and negative words, as well as their corresponding sentiment scores. For data labeling, during the data labeling process, we determined which data belongs to the categories of training and test data, and the distribution ratio between training and testing data is set to 70-30 ratio of the total data. The focus is on the sentiment field, as the study specifically involves calculating positive or negative sentiments. Lastly, we conducted an accuracy test, which is also a very tedious process, so I'll I'll only introduce the accuracy testing we utilize, as it will be explained further later on the results and discussion. These accuracy tests includes the accuracy, specificity, sensitivity, and precision.
So now we're on to the results and discussion part. So as mentioned in the methods before, lexicon-based sentiment classification matches the words in the data to the words found in the NRC lexicon. So basically what it does is if the comment has a positive word, it will be classified as a positive sentiment. And if the comment has a negative word, it will be classified as a negative sentiment. So Figure 1 shows the data sets most frequently used positive and negative words. As you can see, the top three most frequently used words in the classified positive sentiment are food, good, and place. On the other hand, words like food, place, and disappointment are the most frequently classified words as negative. The two sentiments or classifications have words in common, which are food and place. This means that the reviews were describing the restaurant's food and place. Meanwhile, words like good and disappointed represent the positive and negative sentiments of the customers. Next slide, please. Okay, so as mentioned again in the methods before, we have labeled the data into training and testing data. We have divided the data into 70 and 30%, and our data consists of 1,000 sentiments or words. 700 of the data was used to train, while 300 of it was used as testing data. It was found that 57.29% or approximately 401 of the training data was classified as positive, while 42.71% or approximately 299 was classified as negative. In the testing data, 58.33% or approximately 175 was classified as positive, while 41.67% or approximately 125 was classified as negative as shown in figure 2. Next slide, please. So after conducting an accuracy test and confusion matrix, it was found that the accuracy of the data classification with the naive-based classifier system is 66%. This percentage represents the data that is predicted correctly. If you can still remember on our past lesson about it. Furthermore, the recall test yielded a result of 69.73%, indicating the proportion of actual true instances in the data that were predicted correctly. If you can notice, it does not match the recall or sensitivity that was calculated by the system. It is because we have manually calculated the metrics just to make sure. The same goes for the precision. It showed that 73.71% of the predicted true instances were correctly identified as illustrated in figure 3. Next slide, please. Now, for the conclusion, the accuracy results of sentiment analysis in the study lead to the conclusion that public reviews of a specific restaurant, analyzed using two methods, lexicon-based and naive-based classifier, showed a positive tendency. Next is for the recommendation.
After we made the project about the sentiment analysis on restaurant reviews, we decided as a group that to recommend for future researchers. First is to enhance our machine learning model. You can use either naive Bayes or random forest classifier. And also in acquiring data set, feature must be separated for future researchers. And also the data we're going to acquire will be much better if it is within the UP Mindanao premises for a substantial and beneficial data set for us all. That's all. Thank you.
Thank you so much. Congratulations. Sentiment analysis team. This problem is really relevant in the case of improving services, not only in restaurants but also in other offices, especially if you apply this in the UP Mindanao setting. because if you want to really improve, then we have to listen, no, to our clients and to our customers. And one of the ways to continuously, get feedback from them is through uh, uh, getting some feedback from them, and then for analyzing, you can apply these automated techniques, machine learning techniques and data science techniques to automatically get the sentiments of the client. So I hope you can extend this to other applications, and it would be nice. It would really be nice if you can apply this in a given manner. So thank you and congratulations. So the next team will be presenting about predicting consumer shopping cart abandonment in e-commerce stores. This is done by Arita Argel Castigon, Johan Del Piero, and Adrian Gel Valdez. So take it away.
Good afternoon, everyone. Before we will start, let me introduce to you our data science project, which is the predicting consumer shopping cart abandonment in e-commerce stores. So here are the table of contents, the background of the problem, objectives, methods, results and discussion, conclusion, and recommendations. Next slide, please.
So background of the problem. In the ever-evolving landscape of online retail, shopping cart abandonment remains a formidable challenge that demands our attention. With that, shopping cart abandonment is a frequent phenomenon that many e-commerce stores experience. Despite having an appealing range of products, businesses often find that customers abandon their shopping carts before completing their purchase. For any business to improve their online shopping experience, understanding why a customer chose to not proceed with their purchase is important. Reasons as to why consumers chose to abandon their shopping carts can range from many factors. These include unexpected costs from shipping fees, taxes, and additional charges, complicated checkout processes, lack of guest checkout, and unexpected surveys and forms and distrust in the website. By meticulously examining and proactively mitigating the factors contributing to cart abandonment, we position ourselves not only to enhance customer satisfaction, but also to fortify our standing in the competitive e-commerce landscape. So for the objectives of our study are the following. First is to provide a more personalized online shopping experience to reduce cart abandonment. Second is to develop predictive models specifically using supervised learning algorithms, the logistic regression, random forest, and k-nearest neighbors to forecast whether an online consumer is likely to abandon their shopping cart, determining which model exhibits the best predictive capabilities. The comparative analysis of these models with a keen eye on their predictive capabilities is instrumental in determining the most effective tool for anticipating and addressing shopping cart abandonment in our e-commerce system. Methods of our project encompasses two parts, which are the data collection and the feature selection. In terms of our data collection, the data set in our study was obtained from Kaggle, a platform for data science and machine learning. The data set is titled Consumer Shopping Trends, which was uploaded by Saurav Banerjee with 3,900 entries. In
terms of our feature selection of our study, we picked the following as our predictor variables: the review rating, payment method, shipping type, number of previous purchases, preferred payment method, and frequency of purchases. And that's all for the background of the problem, objectives, and methods of our study. I will now give the floor to Ms. Arita for our exploratory data analysis of our project.
So here's the exploratory data analysis of our project. So as you can see in this count plot, we can see that the frequency of abandonment, which is counted as 1, varies depending on the different factors such as category, gender, and season. The data is organized into subcategories to facilitate the comparison and analysis of abandonment trends. So for the accessories and clothing categories, show the highest abandonment rates. And this suggests that these items are more likely to be abandoned during the annual shopping period. For the footwear, also has a lower abandonment rate. And in terms of gender, the fall season sees a higher abandonment rate for female, while spring and summer seasons show equal abandonment rates for both female and male. In the winter season, male is most likely to abandon their items, while female is least likely to abandon. In the frequency of purchases category, weekly and fortnightly have the highest abandonment rates, and monthly and quarterly purchases show a lower abandonment rate. Biweekly and every 3 months have even lower abandonment rates. For the next count plot, we can observe that in terms of size, there are a fewer abandonment carts in the XL category compared to other sizes. However, there is still a considerable number of abandonment carts in this category. In terms of payment method, there are fewer abandonment carts using cash compared to other payment methods. Additionally, the number of abandonment carts using credit card, debit card is much lower than that of other payment methods. In terms of shipping type, the standard shipping type has the highest number of abandoned carts. On the other hand, the express and free shipping next day air shipping types have fewer abandoned carts. In terms of subscription status, there are more abandoned carts with no subscription status compared to those with yes subscription status. And the third count plot, the abandonment status by discount applied shows that customers who receive a discount are less likely to abandon the transaction. For the preferred payment method, it indicates that customers who preferred PayPal are more likely to abandon transaction. While for promo code used, it indicates that customers who use a promo code are less likely to abandon the transaction. For the box plot, abandonment status by age is skewed towards 0, indicating that customers in older age groups are less likely to abandon their shopping carts. For the review rating, also has a high portion of zeros, indicating that customers who provide higher ratings to produce are less likely to abandon their shopping carts. For the purchase amount, it is highly skewed towards 1, showing that customers who make larger purchases are more likely to abandon their shopping carts. And for the previous purchases, it is also showing 1, suggesting that customers who have made previous purchases are more likely to abandon their shopping carts. For the last box plot, as you can see, in contrast, the items that have not abandoned seem to be distributed randomly without any clear patterns, for item purchase, colors, and location. But there are some locations with more abandoned items than others. So this suggests that location may have a significant impact on abandonment rates. So overall, we can analyze from the pie chart and conclude that the majority, or the 69.9% of the total samples, falls into the category of 1. On the other hand, a smaller proportion, 30.1% of the total samples, falls into the category of 0. Hence, the pie chart demonstrates the category 1 is the most likely to abandon the task.
So hello guys. So mahaba masyado rant ni Aretha. For our next step, we transformed the data for our models. We made a model matrix encoding categories and leaving out some variables to avoid issues. Actually, dito na part, tinulungan kami ni Sir Vlad kasi doon na part na mali kami and tinuruan niya kami paano gawin yung model matrix. So the categorical variables like category and gender became numbers. We used binary columns for each category, with 1 if the observation matched and 0 if it didn't. This made sure our model didn't assume any order between categories. The resulting model matrix has all the features in a structured way, where each row is a piece of data and each column is a feature. We also scaled continuous variables like purchase amount and number of previous purchases to work better with our machine learning algorithms. In our analysis, we used 3 different methods, namely logistic regression, random forest, and k-nearest neighbors. Well, each chosen for its strengths in dealing with our study's goals. Logistic regression is straightforward, helping predict whether customers will abandon their shopping carts based on features like review ratings and payment methods. KNN focus on localized patterns, predicting abandonment by comparing a customer's behavior to their nearby counterparts. Random forest is chosen for its ability to handle complex relationships in data. For our model training, we split our data into 70% for training and 30% for testing. We also used validation like k-fold cross-validation, and it repeated for 3 times. And we adjusted parameters like hyperparameters and class weights to deal with the imbalances in our dataset. So for the logistic regression model, the metrics are accuracy 54.15, precision 32.58, recall 48.86, F1 score 39.14. The specificity is 56.43. For k-nearest neighbors, the metrics are 69.12%, 40%, 5.11%, F1 score 9.11%, and specificity 96.70%. Lastly, for the random forest, the results for the metrics were 70% accuracy, 33.33 precision, 0.28 recall, 0.565% F1 score, and 99.76% specificity. When comparing our models, we found that random forest performed the best overall with an AUC score of 0.8. However, there's room for improvement, especially in sensitivity and specificity metrics. The KNN model struggled to detect positive instances, possibly due to parameter choices. The random forest had excellent sensitivity, but slightly higher false positive rate. While there are areas to refine, the models provided valuable insights into predicting shopping cart abandonment. That is all for our presentation. Thank you.
Congratulations, abandonment team. So I hope that you are not one of those people who abandon the cart. So this problem is really very relevant, especially in the case of online commerce, because if you are going to sell online, and there are people who actually promise to buy something and later decided to rescind the purchase, then that may also, you may also incur cost, especially if the item is out for delivery and suddenly they decided not to pursue the purchase. So I think there's a lot of things that we can expand this problem into, and maybe we can apply these different models. Really, there is imbalance problem in the data, especially that there's if you are going to compare it, one of the findings is that women tend to abandon often compared to men, but maybe because there's just a lot of women or a lot of female buyers in the data. So we can still improve, I believe, with the model, and the applications is really very relevant in terms of e-commerce. So congratulations, team. Job well done. Okay, so let's proceed to our Next one, which is on machine learning application in traffic forecasting, completed by Catherine Banak, Giselle Gadi, and Hermes Benz Munta.
So, hello everyone, a pleasant day to the audiences. Today we are going to present our study titled Machine Learning Application in Traffic Forecasting. So, as our society continues to grow, so does the number of vehicles on our roads. The surge of vehicles not only leads to economic losses, but also takes a toll on our daily lives. A recent survey from Statista 2022 reveals that commuters in our country spend a substantial amount of time in congested roads. 29% of these participants spend about 15 to 29 minutes of their day commuting, while 26% spend around 30 to about an hour of their day for it. Such statistics show the impact of traffic in our daily lives. Imagine if we could have saved up some time commuting, we could have done something more productive instead of being stuck in an agonizing traffic situation. Now, it isn't just that. Traffic congestions bring about more nuances, according to PN Karapanagander 2018, aside from the time wastage and unforeseen events that cause a surge in traffic. The amount of vehicles stuck and concentrated in such an area consume much more fuel, which translates to a loss in resources. Air pollution is then produced from these traffic situations, which further harms the environment. There's also the noise that comes from the honking cars, and roadways being congested lead to a decline in the road safety over time, which of both are not good for our well-being. To somehow remedy traffic congestion in the country, the bus rapid transit system has been introduced. This system dedicates lanes for buses, not only decongesting open lanes for private vehicles, it also leads to a decrease in gas emissions, which is good for our environment. Sorry. Even though such efforts exist to optimize the traffic situation, there's still much more we can do to improve it.
And so, in order to do some to plan our objective, here are our objectives rather, sorry for that. So first, we aim to implement data-driven strategies to help commuters avoid congested areas in peaks, as well as to better allocate transportation resources and optimize model parameters, and develop and train an XGBoost model for traffic forecasting using historical data, and most importantly, improve the overall commuting experience by enhancing predictability. And so, in order to make our objectives a reality, here are the methods and techniques we've used. First, we did some data exploration wherein distribution analysis was used. The measures of central tendencies help us identify the characteristics of our data. It helped us determine how spread our data is. And because of that, we also did some data visualization in order to further visualize further visualize the behavior of our data. We made use of bar plots and box plots. Now, we did some data pre-processing. We did some column pruning wherein we removed an identifier, a column named ID, as we noticed that it did not contribute to our data analysis. Also, we did some data type conversion in order to ensure proper extraction of features, as well as to prevent numerical misinterpretations. And so, with the help of data type conversion, we were able to do some feature engineering. We were able to extract features from datetime column, more specifically hours, days, months, and years. And now, let us move on to our model building. So first, we did some model selection. We've tested our model, our data with a lot of model, and we've resulted to XGBoost model as it outperformed the remaining models. XGBoost model is an extreme gradient boosting wherein it's a machine learning algorithm that excels at predictive model problems.
And so we moved on to model training. So before actually training our model, we split our data into 70 to 30%. And then to test our data, we've used our model to test 70% of our data, and the performance was evaluated using the key metrics such as root mean squared error, as well as the mean absolute error and the accuracy. Also, to further understand or analyze the effectiveness of our model, we've allowed our model to predict the unseen data, which is the 30% of our data.
So now we're gonna proceed to our results and discussion. Here we're gonna discuss the performance of our XGBoost model through the application as presented by Kath. So here's our graph. This graph of the test set shows a great representation of the XGBoost performance. We can see that there are only a few actual or yellow lines visible as the model was able to capture its patterns effectively enough, as shown by the blue marker. The RMSE showing a little deviation from the training and test set shows that the model was able to sync well with the available traffic data. The mean absolute error also indicates little difference from the actual and forecasted values, which matches with the RMSE results. For our accuracy metrics, it also aligns with the MAE and RMSE as shown on these percentages, further showing the model's effectiveness in predicting patterns in the data. Here we have the forecasted 6 months of traffic as predicted by the model. Looking up our data, the 1st of July of 2017 is a Saturday, so we can get a picture of the traffic in this graph where we could see each section representing each 1 week, each pattern representing each 1 week. And here we can see that it dips in Sunday, and then its lowest point, we can assume that it's Monday. It rises and settles into the middle of the week, settles down, and then goes back again. It shows a pattern. So this shows that the model effectively captures the pattern of the traffic. We can see that the model captures the trend of the traffic forecast, further showcasing the capability of the model to predict traffic.
All right, so to wrap up, the XGBoost model excelled in accurately forecasting the traffic patterns, making it invaluable for transportation management and urban planning. In reviewing the performance of the XGBoost model, we observed its ability to make precise predictions on both the training and the test sets with a significant high level of accuracy. Notably, the model showcased its proficiency in forecasting traffic trends for the next 6 months. Hence, we concluded that the integration of XGBoost model emerges as a data-driven strategy that holds extensive implications for establishing urban transportation systems. This phenomenon helps authorities manage peak hours, allocate resources wisely, and enhance public transportation scheduling. Plus, it boosts road safety by identifying high-risk areas. Our venture into machine traffic learning for forecasting has not only achieved its objectives but has also illuminated avenues for enhancement. Looking forward, we recommend proposing the development of a system that not only predicts traffic patterns but dynamically suggests optimal routes to commuters in real time. We also recommend establishing collaborations with transportation authorities to integrate predictions into their traffic management systems. The last is to explore the integration of weather data as an additional variable in traffic prediction models. So that concludes our report. We extend our appreciation to all of you for diving with us into the world of transportation and listening until the very end. Thank you.
Thank you, traffic team. So I think again, this is one of the potential application of data science now from the agriculture to e-commerce. Now we go to the transportation problem. And in fact, if you're going to if you are traveling in Davao City, you might encounter heavy traffic during rush hours. So this can be a good model to somehow predict, although it's quite predictable already when it's going to have a buildup of traffic, especially on junctions. But we can use this model to forecast traffics, and main application actually of forecasting is to help us in planning in planning the maybe road networks or some policies that the government can implement to ease the traffic problem. And I believe that this model that you've developed can be used as a forecasting model for predicting traffic given some scenarios. So congratulations, traffic team. Job well done. Okay, so let's proceed to the next team, which is on enhancing student experience through AI, implementing a chatbot system at the University of the Philippines, Mindanao, completed by Shara Bingan, Shamiros Nalangay, and Cristeline Guerrero. Take it away, team.
A pleasant afternoon to everyone. At this moment, our group, composed of Cristeline Guerrero, Shara Maybingan, and yours truly, Chamers Faith Malangay, is going to present our data science final project entitled Enhancing Student Experience Through AI, implementing a chatbot system at the University of the Philippines, Mindanao. For the background of our problem, the University of the Philippines Mindanao faces a challenge in providing immediate and accessible information for its students, especially the freshmen. Many students have numerous questions such as the location of specific buildings, library hours, course information, and many more, which can be time-consuming and inconvenient to answer manually. Although the University of the Philippines Mindanao already has an official website where information about the university is available, not all frequently asked questions of the students are answered there. Questions like dorms, apartments, canteens, and fares are not discussed on the website. Additionally, navigating the website to find the answer to their question is exhausting and time-consuming. So, to address this issue, we developed a chatbot system that can efficiently respond to these frequently asked questions, making essential information readily available 24/7, anywhere, anytime. Now, for the objectives, the main objective of our project is to develop a university chatbot. Then, the chatbot should be able to answer the students' common questions about the university. And lastly, is to make that chatbot accessible for everybody 24/7. Now, for our data, the data of this project was collected through direct interviews and online surveys from various courses and colleges at UP Mindanao. The collected data consisted of common questions frequently asked by students. First, the data is initially loaded from a JSON file and organized into a data frame. Then, text data is processed, tagged with intents, and encoded for model training. Then, the dataset is split into training and validation sets for evaluation. Then, tokenization is performed to convert text data into a format suitable for model input. Then, datasets are created specifically tailored for model training and validation. And lastly, the model is trained using the prepared dataset.
And now, let us go into the technique of the chatbot. So, this chatbot utilizes a PyTorch-based neural networks models. So, the intent RNN model and architecture employing recurrent neural networks, specifically LSTM layers for the intent classification. And for the tokenization, implemented a tokenizer to pre-process the input text and convert it into the tokens for the model. And for the model architecture, intent RN model had an embedding layer, LSTM layer, dense layer, and classifier for intent classification. And for the model training and validation, training was performed using an Adam optimizer and cross entropy loss for a specified number of epochs. Stratified keyfold cross-validation was used for model evaluation, splitting the dataset into training and validation set. As well for the responses, intent classification. The dataset employs intent classification techniques to identify the user's query. And the length embedding, the dataset uses HTML lengths to embedded within the responses to redirect users to relevant web pages for detailed information. Ako na ba? Dili pa ako ba?
Moving on with the results on discussion, the chatbot was able to classify user intentions and deliver relevant responses in accordance with identified intent. The provided dataset helps the system to identify user intent effectively and provide appropriate responses or links based on those intents. For the demonstration of the chatbot, as you can see, for instance, if the user would want to ask about the grading system here in UP Mindanao, the chatbot will respond as seen here as highlighted about the grading system here in Mindanao. We also utilize the use of HTML links to provide further information and a comprehensive information about the grading system here in UP Mindanao. Again, also if the user would want to ask about what does INC mean? As you can see here, the chatbot will give the answer about what is the meaning of INC, how it is acquired, and how it will be removed. That's it for the results and discussion. Moving on to the conclusion.
And now for the conclusion. So in conclusion, the implementation of the proposed chatbot system at the University of the Philippines, Mindanao represents an innovative solution aimed at efficiently disseminating information to students, specifically to newcomers to the university. Through the utilization of AI technology, this chatbot not only addresses inquiries but also ensures a seamless and accessible 24/7 support system, enhancing the overall university experience for students. Beyond its benefits to students, this system also alleviates the workload of faculty and staff by handling routine queries, allowing them to focus more on integrate tasks. The university chatbot AI system developed in this project serves an interactive and comprehensive tool, effectively addressing various phases of user input. This project contributes significantly to the discourse surrounding AI integration in education, emphasizing the practicality and efficiency of chat system in fulfilling information needs within the university environment.
For the recommendations, we need to understand that this chatbot system has limitations. Exploring architectures other than RNN, such as transformers like GPT or GPT-2 or hybrid models that combine CNNs can increase model performance because transformer-based models excel at comprehending contextual relationships in text data. Furthermore, extending the dataset also to include a more varied range of user queries and linguistic patterns can also improve the model's comprehension and reliability in accurately predicting intent categories. That would be all. Thank you.
Thank you, chatbot team. So I think the chatbot team would really give a tremendous contribution, no, in improving the services that offered by UP Mindanao, especially that one of the most common complaint is that there's lack of personnel, no, to entertain clients or students' requests and queries. So with the implementation, hopefully, no, you will pursue this type of study, and not only for student concern, but also for incoming students who might be interested to enroll in our different degree programs, especially in the data science program. So good job, and I like that you have also presented a short demo on the capability of the chatbot. So maybe I can connect you to the college secretary, whom you might be able to help them in the developing this chatbot system and maybe coming up with a pilot implementation of the chatbot. So congratulations, Team Chatbot. Let's now proceed to the next team, which is on predicting fish abundant times using chlorophyll a tool for sustainable fishery, completed by Carl Cyril Malumpage, Jimina Buhian Haitin, and Vanessa May Perrore. Take it away.
So, good afternoon, everyone. Today we will be discussing about the project that we've developed, predicting fish abundant times using chlorophyll a tool for sustainable fishery. This presentation includes the background, data and method, result and insights, conclusion, and recommendation of our project. So the abundant aquatic resources in the Philippine Sea support Filipino livelihoods and serve as a vital food source. With its abundant marine resources, Filipinos continually face cases of illegal, unreported, and unregulated fishing. This state of inconsistency threatens marine biodiversity, reducing its quality and volume. Phytoplankton, as the base of aquatic food webs, is a crucial component for understanding the productivity and ecological health of aquatic ecosystems. It indicates nutrient availability that can be consumed by marine life in a water body, which denotes the productivity of the ocean. And chlorophyll A, the primary photosynthetic pigment in phytoplankton, serves as a convenient indicator of phytoplankton abundance and biomass. With the help of satellite remote sensing, where it has become possible to collect data on Earth, including data on chlorophyll A concentration, and having chlorophyll A as an indicator of phytoplankton biomass, our objective is to create a model that predicts chlorophyll A values as an approach to promoting sustainable fishing practices. In achieving this, satellite images for chlorophyll A data were downloaded from NASA's Ocean Color ACOMODE satellite data. The downloaded data was then extracted using the CDA software for its numerical values for the specific location in the Philippine Sea, and it was then divided into training data and test data. So for the methods, Carl will be discussing it with you.
So, hello. So, a pleasant afternoon, everyone. I will be going through the process of how we process the data into creating the model. So, firstly, after after processing the data, we then had to clean it. So, we had to clean it because after we gathered the data, it had missing values, and at the same time, it is also of the wrong data format. The reason being on why it is essential to clean it is that in R, the built-in functions of the models will not recognize certain data types, and at the same time, it will have gaps if the data has, it has missing values. Next, after cleaning the data, is that we had to create the time series plots and had to model it. This allows us to fit the time series data to the model called SARIMA. SARIMA, or Seasonal Autoregressive Integrated Moving Average. This is the model that is specializes with seasonal data, which what we have. After that, when the data has been fitted to the SARIMA model, we will then use a function in R called forecast. With that, we can determine the values of chlorophyll A over certain time plots. Of course, the model has never seen the data that we had it forecast. We then take the visualization of that forecast and compared it with our actual data, aka the test data. After the comparison, we had to determine the accuracy of our forecasted data, and after that, we will then proceed to the results and the conclusion.
Oh, so thank you for that, Mr. Malupanga, and I hope everyone in here has found the presentation insightful so far. My name is Vanessa, and now I will be exploring the results and discussion. So the graph shown is a time series plot that displays the predicted values generated by the Sarima model. It compares the actual chlorophyll A data against forecasted values spanning from 2019 to 2023. The plot includes a red dotted line representing the actual chlorophyll A data values, while the blue solid line represents the forecasted or predicted chlorophyll A data values generated by the training data from the years 2003 to 2018. To assess the model's performance, we use the root mean squared error or RMSE. The model has an RMSE of approximately 0.0113, suggesting that on average, the predictions made by the model have an error of around 0.0113 units when compared to the actual values. Since chlorophyll A concentration is measured in milligrams per cubic meter and has a range of values from 0.025 to 0.08, an RMSE of 0.0113 is relatively small. This represents a percentage error of approximately 20.58%. Considering the natural fluctuations of chlorophyll A concentration, this level of error is deemed acceptable. Now, as for the conclusion, in our chlorophyll A prediction model, we've demonstrated the capability to forecast future data. This ability is indispensable when it comes to potential innovations. Unfortunately, our data sample did not yield any meaningful results within the context of marine life. Of course, that is due to the fact that data regarding chlorophyll A and the Philippine Sea in particular is lacking when it comes to the correlation of chlorophyll A and marine life. Although it is true that they correlate, the fact stands that each sea may have different variables that greatly affect this correlation. Despite having results, we are careful to not jump to conclusions before doing more research about its correlation, specifically in the Philippine Sea. That is one of the limitations of this project, of course. What we are able to demonstrate is still significant because it implies the possibility to predict the concentrations of chlorophyll A, and with enough refinements, this project could be revolutionary to the fishing industry. Next. Now, moving forward to the recommendation, we recommend that the next time the data is analyzed to improve results and prove correlation is to do more research and include more variables in the data. This will make it so that the evidence between its correlation is much more reliable. Now, in terms of improving accuracy, we recommend using a lot more data for training than what we have used in this project. Doing so would improve accuracy and would make insights more substantial. So that would be all for our presentation. Thank you.
Thank you so much, Chlorophyll team. I think that is a very nice study on dealing with proxy measures on determining the fishing abundance on the just using the chlorophyll. And also the use of satellite data is really relevant nowadays, especially that we are just using data from remote from satellites, no? So this is encompassed in remote sensing, and you'll be able to learn more about this in one of your courses in the data science program. So congratulations, team, and let's proceed to the next team, which is the balancing priorities, analyzing the impact of health expenditure on the gross enrollment ratio of leading countries in education, completed by Francis Cajano, Jade Rocco, and Mary Antoinette Santillán. So take it away.
Pleasant day, everyone, especially to our professor, Dr. Vladimir Kobayashi, my classmates and fellow presenters, and viewers from our various streaming platforms who are with us this afternoon. It is our pleasure to share our very first data science project to you all. I am Francis Carlo Cajano, and with me are my colleagues Mary Antoinette Santillán and Jadelyn Rocco. Our data science project is balancing priorities, analyzing the impact of health expenditure in the gross enrollment ratio of leading countries in education. Today, we will give you a background of our project and the problems by which our project is founded, an insight into the data we used, the techniques we performed to derive the desired results from our data. We will also share to you our findings, and finally, our overall conclusion, recommendations, and insights. Now, at this point, allow me to begin framing the problem by two statistics provided by the Philippine Statistics Authority. First is 18.6% of Filipino children are not enrolled to school. Second, of the Filipinos who are supposed to be in tertiary education, only 33% of those are actually enrolled. Internationally, we are looking at the percentage of the Philippines population with at least an undergraduate degree in comparison to that of Italy, Poland, and France. And as we can see, the difference is astounding. What do this tell us? This tells us first that there are a significant challenge in education system in the Philippines. And second, there are things and factors that hinders Filipino access to education. However, we wish to tackle beyond the already well-documented problems of poverty and class struggles. What we want to explore in this project is an area less associated to education, and that is the country's health expenditures. Because if we look at each country's percentage of GDP spent on health, we can see almost the same pattern. The same countries that spent more on health are the same countries who have high percentage of degree holders in their population. And that is what we want to prove. If whether or not there is indeed a correlation to a country's health expenditure to their gross enrollment ratio. Continuing on that, we have two main objectives. First is, again, to explore the correlation of a country's health expenditure to their gross enrollment ratio. Second is to know what economic health expenditures in terms health economic indicators in terms of expenditures positively and negatively affect a country's gross enrollment ratio. We collectively believe that the results of this study will serve as a guiding principle for how organizations and institutions approach the problem of education in the next time around. And with that, allow me to give you a rundown of our data set that we used in this project. There are two groups of data set, that is the education data set and the health data set. All of these data sets are conveniently available at Kaggle in comma-separated value files. The data contains features such as the country name, country ISO 3 or the country code, year observation, indicator name, its corresponding code, and corresponding value. This is true for both education and health datasets. As for the education dataset, after we combine the dataset of France, Italy, and Poland, we ended up with 830 variables and 186 observations. After the same process, the combined health dataset contained 181 variables and 186 observations. Our dependent variable will come from the education data set, which is the gross enrollment ratio, primary to tertiary of both sexes. So basically, this is just the ratio of academic turnout from primary to tertiary of both sexes in relation to a country's population. As for the independent variables, we have a handful of them, such as how much of a country's GDP is spent on health, various domestic general government health expenditures, which is basically the spending of government in healthcare within its borders. We also have out-of-pocket health expenditures, which are the personal spending of the population towards healthcare. Beyond that, we also gathered additional data from years 2019 and 2020, so we can test if our model are still applicable in the more recent years. The data we collected are just the same, only this time it is provided by the World Bank Open Data. Now, at this juncture, I will be passing you to my colleague, Miss Mary Antoinette Santillan.
So, moving on with the techniques. In analyzing the data, we mainly use the multiple linear regression. This is a powerful statistical method with various applications. But first, let us understand its purpose and why it is a valuable tool in our study. Our goal in using multiple linear regression is to predict a dependent variable using multiple independent variables. This method is particularly useful for uncovering relationships, understanding variable impacts, and making accurate predictions. Next slide, please. Now, let's ensure the reliability of our results by delving into key validation techniques. First is F-statistics. We employed F-statistics to assess the overall significance of our model. It helps us understand if our model is providing meaningful insights. Next is the multiple R-squared. It indicates the proportion of variability in our dependent variable that our model explains. A higher value signifies a better fitting model. Next is the adjusted R-squared. This takes into account the number of predictors in our model, providing a more nuanced measure of goodness of fit. Now let's discuss the tools and plots we've utilized for validation. First is the Shapiro-Wilk test. We've used the Shapiro-Wilk test to check the normality of our variables, ensuring that our data adheres to the assumptions of the linear regression. Next is the Kendall-Rank correlation. This coefficient helps us assess the monotonic relationships between variables, adding depth to our understanding. And next is confidence intervals. Confidence intervals are crucial for evaluating the significance of predictors in our model, providing a range of possible values. Next slide, please. Next are the diagnostic plots. Our diagnostic plots offer visual insights into our model's performance. First is the residuals versus fitted values plot. This plot helps us assess linearity and homozygosity in our model, ensuring the validity of our assumptions. Next are the QQ residuals. This check if our residuals follow a normal distribution or another key assumption. Next are the scale loops. This identifies outliers and assists us. This identify our potential outliers. Now let's move on to the analysis phase. We put our model to the test.
So now for the data analysis. For the summary model and results and discussion, with the use of multiple linear regression, we have concluded that out of all independent variables, among them are 4 statistically significant. We have the current health expenditure per capita, which in 1 unit increase, it is associated with estimated increase of 0.08735 units in G enrollment and or gross enrollment. And the other three, the independent variables, are negatively associated with the gross enrollment. We have the percent of domestic general government expenditure, where it decreases 2.066 units in every 1 unit increase of gross enrollment. And we have the domestic general government health expenditure per capita, which decreases 0.1149 units every unit increase in gross enrollment. And the last one is our out-of-pocket expenditure, which percent of our current health expenditure, which decreases 0.4107 units in every unit increase in gross enrollment. And with here we have our RSE, or the residual standard error. We have 1.301 RSE, which indicates that our model is a better fit. And in terms of the accuracy of our model, we have here, we can say that this model does a decent job of explaining the variation in gross enrollment, because around 84.43% of the differences between predicted and actual values are accounted for by the model. This can be proven by our multiple R squared with its value close to 1. And in our adjusted R squared, it shows that the statistically significant independent variables have 79.49% accuracy. Lastly, in our F statistics, we can see here that our p-value has a very low value, which is lower than our p-values, which are 0.01 and 0.05, which this concludes that we have strong evidence to reject the null hypothesis, indicating that at least one predictor variable is related to the dependent variable. Next one, we have here our plottings for the results. We have here the residuals versus fitted. This this pattern is suggestive of a well-behaved and effectively fitted linear regression model. And another plotting is for our predicted versus actual gross enrollments from years 2019 to 2020 in 3 countries, from France, Italy, and Poland. We have here, we can see here that only minimal disparities between the predicted and actual values is, this suggests that our model has successfully encapsulated the intrinsic patterns that is present in the dataset. And now for the conclusion, we have Ms. Antoinette Centurion.
So to conclude everything, our analysis reveals a strong correlation between healthcare costs and academic performance in the Philippines. This emphasizes the crucial role of health expenditure variables in shaping the educational environment. The insights gained from this analysis have the potential to inform strategic decisions in these domains.
Now for our recommendations. We have identified 3 paths that we think will expound the already established results of this project to deepen our understanding of this underlying connection of health and education. First is the exploration of data beyond the countries we have tackled. Again, that is Italy, Poland, and France. They can also go beyond leading countries and consider the developing ones to establish whether or not the same pattern of correlation exists. Second is to explore other sectors beyond the health sector. Maybe there are more factors that affect the accessibility of education beyond what meets our eyes. And lastly, if they wish to still tackle the effects of health into education, they can measure other factors in health beyond the economic indicators. And with that being said, on behalf of my colleagues Mary Antoinette Santillan and Jadeline Rocco, we thank you for your undivided attention throughout our presentation. Thank you very much, everyone.
Thank you, health team. So I think this is already a application, no, at the macroeconomic perspective. So maybe we cannot really say directly that it's the healthcare investment that leads to a higher gross enrollment ratio, no, but rather it's an indicator, which was rightly mentioned by the team, by the health team, that may indicate, no, because if the country is keen on investing on its health, no, the health system, the health of its citizen, then people will be more or less encouraged, no, to pursue higher education. So this can be really a nice way to look at how we can in the Philippines, how we can also encourage people to pursue or finish their education. So thank you so much. We are down to the last two teams. So let's have the second to the last team, which is Empowering Road Safety, a Python-powered driver drowsiness detection system by Kyle Scale Bardoquillo, Lady Jen Giverola, and Beyonce J. Ramos. Take it away.
Good afternoon, Dr. Vladimir Kobayashi, and a warm welcome to our presentation showcasing the Driver Drowsiness Detector project. I am Lady, and along with me is Kyle and Beyonce. So let's talk about road accidents. They cause a lot of deaths worldwide, about 27.5 fatalities for every 100,000 people. Drowsy driving is a big part of this problem. In the US, from 2011 to 2015, it caused around 4,121 deadly crashes and injured 3,662 people, and that's about 2.4% of all deadly crashes and 2.5% of the deaths during that time. Even though we don't have enough numbers or exact numbers for the Philippines, we know that drowsy driving causes a lot of accidents here too. So our final project draws inspiration from Roxo Wu and Wong Deng's study on real-time driver drowsiness detection system using facial features. We aim to develop an innovative system. Focus is on creating something more than just technology, and we're aiming to build a driver drowsiness detection system that's not just effective but also trustworthy. So moving on to our objective, first is improving road safety. Of course, we want to make roads safer by preventing accidents caused by tired drivers. We plan to use a dependable warning system to alert drivers when they're feeling sleepy, or we want to help them make having stop accidents or save lives. So next is the user-friendly implementation. We want to make our driver drowsiness detector system easy to use for everyone, and our goal is to create a simple and straightforward design that anyone can understand easily. So this will make it easy to put this system in cars. And last is for the positive economic impact. Though somehow you may think it is unrelated, but actually it's not. So besides saving lives, our work also has a big impact on money. If we can stop accidents caused by tired drivers, it means we'll spend less on medical bills, fixing cars, and insurance claims. It also means people won't miss work because of accidents as much, so we'll save money there too. So in essence, our project isn't just about technology, it's about making roads safer, improving lives, and positively impacting the economy by preventing road accidents. So that would be all for the project objectives and for the background of the studies. So I will now give the floor to Kyle.
Good day, everyone. Let's now proceed to the methods of our project. First is the data collection. This project utilizes a webcam as a data source for capturing real-time facial images. The OpenCV library is employed for video capture, and the captured frames are then processed to extract facial landmarks. Next is the tools and technologies. First is the OpenCV used for image processing and capturing video frames. Then the DLive employs for facial landmark detection. And lastly, for the Pygame utilization for playing alert sounds. Then for the models and algorithms, the key algorithm employed is based on calculating the eye aspect ratio, or in other words, is EAR. The EAR is computed using Euclidean distances between specific facial landmarks. The detection model utilizes a frontal face detector and a pre-trained shape predictor model. As the project is focused on real-time detection, there is no traditional training phase. Instead, the EAR is calculated for each frame, and a drowsiness alert is triggered if the calculated ER falls below a threshold for a specified number of consecutive frames. Lastly, for the implementation, we used Python as for the coding environment. Then let's proceed for the demo. As you can see, I am screen sharing our code and I will be running it now. A moment, please. Oh, wait. I need to stop my share for a sec. A minute, please. Okay, let's screen share my photo. Wait. Okay. I guess you can see my image right now with a green circle in two of my eyes. Okay, so let's experiment the project. First, let's begin by closing one eye. Okay, then for the closing for both eyes. Okay. Wait. Okay. Okay, I'm sorry for the inconvenience. My hair is a bit too long for now, and it renders my what we call this, my eye. So okay, let's proceed back to the presentation slide. And before we end the demo, I will share to you that we can also adjust the sensitivity of the system by changing the ear threshold. The ear threshold depends on the person's face, the person's hairstyle, because if the threshold will be not optimized properly, it will be triggering alarm sounds in a false alarm method. Okay, so let's proceed to the results and discussion part led by Miss Beyonce, I mean.
For the result and discussion, the image shows an open eye which the system interpreted wide open eyes as a sign that the driver was in a stable and attentive state. And the next picture, the person was closing his eyes, so the model detected a narrowing of the eyelids, activating the alert system, and this resulted in a visual alerts and alarming sounds that we heard earlier in the demo to enhance the driver's alertness. To conclude everything, the project successfully addressed driver drowsiness using a webcam-based detection system with the facial landmarks and eye aspect ratio calculations. The implemented warning system utilizing Pygame and Pygame.mixer demonstrated quick responses to signs of awareness. The model's accurate identification of eyelid movements show its potential to enhance road safety significantly. However, the current method relies on a pre-trained facial landmark detection model like DLive, limiting the direct model comparisons due to the task-specific training data scarcity. Despite this limitation, the project's innovative technology can integrate into a driver monitoring system. This proactive system enhances road safety, aiding accident prevention, facilitating early intervention, and adapting to diverse driving conditions. This benefits the drivers, fleet operators, transportation authorities, insurance providers, and technology developers by mitigating risks associated with drowsy driving. Next slide. To enhance the model for future use, our recommendation focus on four key aspects. Number one, datasets diversity for adaptability. Diverse datasets including the different demographics, environment, and driving scenarios ensure the models encounter various situations. This improves the model's performance across different aspects and enhances its generability. Number two, real-life driving scenario testing. The real-life testing provides insights into the model's durability and reliability in practical situations, revealing its performance in diverse and unpredictable conditions beyond control settings. Number three, human factors exploration for improved alerts. This incorporates insights from human factors into the design of alert system. Understanding human behavior contributes to user-friendly alerts. Collecting users' feedback allows to iterative improvements, ensuring alerts are appropriately timed and tailored to drivers' needs. And lastly, number four, exploration of advanced machine learning techniques. This explores alternative approaches, including advanced techniques like deep learning. These methods may offer improved performance in complex tasks. Investigating alternative helps researchers stay current and adapt techniques that could potentially provide higher accuracy and efficiency. And that would be all. Thank you.
Very nice study drowsiness team. And we can actually, how do you say it, deploy it into your cars, no? If you are driving. Because I have witnessed myself, no, the tragic effect of driving when you are drowsy. And this might encourage no drivers. You can put it in the car to tell them that they are, because you might not even notice that you close your eyes, and you know anything can happen if you are driving at 60 kilometers per hour. So the reaction time of human is 1 second. So that's really very relevant. So I hope you can further improve the model, no, so that it won't be affected by other factors not in. Maybe you can also include yawning as part of the model detection. Because sometimes sa eyes naman, no, kung malaki yung mata, di ba? Medyo mahirapan tayo detect because it's really a bit, I mean, you have to set a threshold, no? Paano naman kung medyo singkit? So there might be some adjustments sa model, and maybe you can also include other features aside from the sa eye. Okay? So that's very nice, and also very nice demo. So thank you. And now we are down to the last presenter. So last but definitely not the least is the project Enhancing UP Eco Jeepney Route Optimization through a Heuristic Ready Algorithmic Approach. This is completed by Franz Sazon, Shin Orongan, and Senjoy Mandalinaw. Take it away.
Good afternoon po, sir. Can you hear us po, sir?
Yes, it's clear.
Good afternoon po, sir. Good afternoon, classmates, and good afternoon to our viewers as well. This is our data science project, enhancing UP Ecot jeepney route through optimization through a heuristic greedy algorithmic approach. The reporters are, again, me, Franz T. Sazan, Shin May Orangan, and Senja Mandalino. Moving on to the introduction.
UP Ikot is a transportation here in UP Mindanao where student benefits for commuting process. It is a jeepney which provides affordability and safety for the students to commute from one building to another building or from Mindanao University to their homes or to other locations. However, common problem that the students encounter, um, we notice that the students often wait in uncertainty. They realize on their intuition for the UP Eco to arrive after classes. Students often wait for a long time after classes, making it tough for them to go to other classes on time. This causes problems like being late for classes in different buildings and struggling managing their time for other tasks. Um, for the drivers, waiting for the students can put them in a bad spot and not knowing when or where the students will show up. This uncertainty leads to results in fluctuating numbers of passengers over time and the drivers making up less money. This study aims to make things better for the students and jeepney drivers at UP Mindanao. With careful route planning, hope to make rides smoother, reduce confusion, and makes everyone experience better. We want to help UP Eco drivers at UP Mindanao by using data science. We plan to make clips that matches students' classes schedules across different campus buildings. According to COCOL JG 2023 to September 27, why route planning is important. Route planning is the process of planning of optimizing routes to get most valuable of the fleet of the vehicles. The route planning process involves a complex set of steps to identify and select the optimal paths for moving people and goods between different locations. This means considering more than distance and time, but also factors like the time window constraint, unique road features, traffic patterns, and vehicles and driver specification among many other variables. In addition, good route planning is essential to achieving positive results. When done right, route planning can significantly impact everything from operational efficiency to financial performance and the quality of customer service. This study, enhancing UP Ecot Jeepney route optimization, a heuristic grid algorithm approach can significantly benefit for the students or the commuters and most especially for the drivers.
Moving on to the data set of our project, if I may switch my tab here, we actually got our data set from the CSRS Mindanao website by looking at the class schedule tab here. And we scraped the data like this, and we managed to put that into a CSV file and generate the CSV file of our project. Here, you can see the number of rows are 1,041, number of columns are 11, and the file type is a CSV. Here we generated our initial observation of the data, which was the distribution of classes based on day. We can see that the trend is among Tuesday, Wednesday, Thursday, and Friday are the most number amount of classes, since that's how UP Mindanao laid out their schedule. You can see that Monday has significantly less than the rest of the days and Saturday as well. Moving on to the techniques and methodologies of our study, we first did some we first did some exploratory data analysis to give us a good sense of where the UP might, where the UP ECOT might, where UP ECOT might prolong his stay. Example here, you can see that around for Monday, you can see that Sport Complex actually has the most amount of classes in this day. It makes sense because most of NSTP classes and the physical education classes are on this day. And we can see that that trend for Tuesday, Wednesday, and Thursday are CHSS and CSM buildings as typical classes for typical courses are normally conducted on that day. And moving on to the algorithm model. Okay, there you go. We employed a
So the technique that was utilized to achieve the objective of this project is called heuristic greedy algorithmic approach. So heuristic algorithm is a way in which it finds optimal solution to an optimization problem. So the greedy is the category of heuristic algorithm in which it finds optimal solution in each stages in order to achieve global optimization. In applying this technique, let us consider these following variables. Let B denotes the set of buildings, which include CSM, CHSS, sports complex, and cultural complex. T as the end times for student classes, and M sub DT as the maximum number of students waiting from each building, D at end time T. So first, we look at the number of classes that will end simultaneously at each building, and then we combine the number of students from each class to get the values of M. So after getting all of the values of M, so let's say that the initial point is at B0, the building with the highest number of students waiting at N time T, or basically the building with the highest M value, will be the next stop of the jeep, and that's the first stage. So for the next stage, we will again compare the M values of each building and determine the best next stopover, and it will continue until the best route at that N time T is produced.
Um, in Figure 3 displays the students' pickup schedule, showing the expected demand for transportation from various buildings on specific days and times. On Mondays, there's a consistent need for transportation at the sports complex throughout the day because of NSTP subject that go. On Tuesday, schedules indicate a mix of morning, lunchtime, and evening classes in three buildings of CHSS, CSM, Sports Complex. And on Wednesdays and Fridays follows a similar pattern, while Tuesdays shows classes in CSM and CHS buildings with different end times. On Thursday, only CHSS and the sports complex have classes, with CHSS experiencing break around 1 p.m. The sports complex schedules classes when CHSS has this break. Overall, the schedule highlights consistent student activities and varying classes and times, proving insights for improving transportation services.
So for the scope and limitation of this project, first, the data source constraints. So the data from the CSRS only shows the fixed schedules of each courses, which means that we don't have any data sets from external events or other activities that will be also held inside the campus. Next, as we mentioned, there are some schedules or courses that are labeled as TBA or to be announced. And that's why these courses are excluded for the algorithm or for creating the program. Third, the inaccuracies are high from this study due to the many technicalities and lacking of data sets, such as the student absences, the weather, and as at the same time is the cancellation of classes. Next is this study only allows drivers to know the maximum number of students waiting, but the size capacity of the jeep is not considered in this project. And lastly, the time frame given is limited, so the testing of the UP code drivers of the given optimal routes are not yet executed. Therefore, the accuracy of this project cannot be determined yet, especially through accurate quantities. In conclusion, this study proves how heuristic greedy algorithm works as an optimization tool that can determine the optimal routes for UP code drivers. Moreover, it helps maximize the number of passengers of UP code jeepney around the campus. The enhancement of the said limitations of this project is what the researchers anticipated to further improve in the following years.
Moving on to the recommendations of this project, we could say that a lot of fields or areas of this study could really be improved, such as the implementation of this route. Uh, the recommendation for number one is we could actually implement this route or test this route for our drivers in order to see if there's an increase in income based on this route or not. Another recommendation is a feedback mechanism for students to comment on the UP consistent. Sometimes an algorithm cannot detect uh, a situation is whether this situation can really holds true for the result based on the algorithm. So a feedback mechanism is a great way to handle those conflicts. Next is integration with an academic calendar. It's also safe to say that our proposed route is quite static and does not account for things such as events, holidays, and such, or also such as canceled classes, which suggests that weeks or the academic calendar is quite dynamic in terms of schedule, which is a limitation for our proposed route, which is a recommendation for our future study. Continuing an implementation to other forms of public transportation within UP Mindanao province. UP ECOT is not the only one that can benefit from this route, but also the tricycle drivers, the other forms of transportation, they could benefit from this route as well and create more income and cater more students who want to get to their classes on time. That's all. Thank you for listening po.
Thank you, UP Eco Team. So I see a lot of projects, no, that tries to solve problems well, not problems, but some emerging challenges in the UP Mindanao. So if I may recall, we have the chatbot, and then we also have the UP sentiment analysis, although the data did not come from UP Main, but there's a potential that we can apply it in UP Mindanao, and of course this UP Eco Jeepney route. So I believe that there's a lot of benefits, no, that UP Mindanao can get from us, data science experts, in terms of improving not only the services, but also the experience in terms of traveling within UP Mindanao. So what I can imagine is that we can maybe install sensors and jeepneys to track the movement, and we can get some more data on the movement of this jeepney within UP Mindanao. But I think this is really a nice start in terms of exploring this problem, because it's the value of a project is not only that it solves problem, but it's also identifying challenges, no, in solving those problems, because it will lead you to to solving those problems in succeeding problems. So at least here we are able now to anticipate if we have some projects that might be related to this, we're able to anticipate different challenges that we may encounter in terms of modeling. So congratulations to the last team. And of course, as I promised, I will announce the grade for the presentation. No, so the grade for all groups is now, I have graded you, and it's actually at least 90 over 100. So congratulations, everyone. So for your specific grade, I will just put it in Canvas so that you can see your specific grade. So I appreciate all the effort that you did, the short time that you have to do this project, and of course, the additional effort and research that you did to make this presentation successful. And I hope that you will continue to research on this specific topic if it interests you. And during your journey as data science students, you will be exposed more on a lot of problems, which is quite different from the problems being given in the classroom. Because in the classroom, the problems are sort of canned problems. So, but in practice, there are some problems that you may encounter that you did not anticipate or you did not think about in advance. And you are actually put in a situation wherein you have to be creative and you have to be resourceful and seek answers to these challenges. So I think that this exercise has already exposed you somehow to the real life practice of data science. So congratulations, everyone, and enjoy the rest of your semester break. Thank you, and goodbye.
Thank you, sir.
Thank you so much.
Thank you, sir.
Well, sir.